Welcome back to the deep dive. Today, I want you to do something for me. Just look around the room you're in.
Right now.
Yeah, maybe pick up the device you're listening to this on, or glance at that cardboard box sitting by the door that you haven't unpacked yet. Or, if you're a photographer, look at the top dial of your camera. You are going to see 3 letters. ISO.
They are absolutely everywhere. I mean, once you start looking for them, you really can't stop seeing them.
It's so true, and usually we just tune them out. It feels like, background noise. It's either a setting for brightness on a camera, or it's some boring bureaucratic stamp that makes a trucking company look official.
Just part of the furniture of the modern world.
Exactly. But we have a stack of research here today, and I mean a serious stack, that suggests these 3 letters are actually the operating system of the modern world.
That's a bold claim, but I really think the sources back it up. We're looking at the architecture of trust today. That's what it boils down to.
It is. And the mission for this deep dive is to connect some dots that, on the surface, look like they have absolutely nothing to do with each other. We are going to try to draw a straight line from the microscopic physics of a camera sensor,
I mean, literally how a photon hits a piece of silicon.
all the way to the macroscopic economic engines of global trade. We're talking about free trade zones, international supply chains, and this concept of the race to the bottom.
It sounds disjointed, I know. You have these very technical articles from photography sites like Contrastly and Petapixel sitting right next to heavy management handbooks on integrated management systems.
And economic reports on export processing zones. It's a weird mix.
But there is a through line. There's a common thread that ties it all together.
And that through line is what we're calling signal to noise.
Right. Whether you are a photographer trying to get a clean image of a bride in a dark church, or a CEO trying to get a clean supply chain across 3 continents, you are fundamentally fighting the same enemy.
Which is
You are fighting noise, you are fighting entropy, you are fighting chaos. And ISO in all its forms is the tool humanity invented to filter out that noise, to get a clearer signal.
So let's start at the micro level. Let's start with the thing I thought I understood, but apparently I've been wrong about for 10 years. Photography.
You and most people. Don't feel bad.
Okay, good. So I am an enthusiastic hobbyist. I have a nice DSLR, and I have always operated under the assumption that the ISO button is a sensitivity button. When I'm in a dark bar and I crank that dial from 100 to 3200, I honestly believed I was telling the sensor, hey, wake up, be more sensitive, catch more light.
That is the intuitive model. It makes perfect sense. It's how it's marketed, it's how the menus are designed, but mechanically and physically, it's a lie.
A lie, that's a strong word.
Okay, maybe a helpful fiction, a useful abstraction. But the sources are absolutely categorical here. ISO does not change the sensitivity of your digital sensor, not even a little bit.
So what is it doing?
Your sensor is a piece of hardware. Its silicon, its sensitivity, its quantum efficiency, if we want to get really technical, is baked in at the factory. It has a base ISO, usually around 64 or 100, and that is it. That is the bucket.
Right.
You cannot change the size of the bucket just by turning a dial on the plastic casing.
Okay, stick with the bucket analogy because that helps me visualize it. I like that.
Great. So imagine your sensor is a grid of millions of tiny buckets, pixels, sitting out in a rainstorm. The rain is the light, the photons.
Okay.
When you open the shutter, you are basically taking the lids off the buckets.
Right.
Rain falls in. When the shutter closes, you put the lids back on. That is your exposure. The amount of water in those buckets is the data you captured. The signal
Right, and me turning the ISO dial.
does not make the rain fall harder, and it does not make the buckets wider. The amount of water, the signal determined solely by the aperture, which is the size of the hole letting light in, and the shutter speed, how long the lid is off. ISO has nothing to do with capturing light.
But, and I know every photographer listening is thinking this, when I turn that dial up, the image on the back of my screen gets brighter. If I shoot at ISO 100 in a dark room, the screen is black. If I shoot at 3200, I can see the image. So something is happening.
Oh, something is definitely happening, but it's happening after the capture.
Yeah.
You're amplifying the signal that's already there.
Amplifying it.
Think of it like a radio in your car.
Yeah.
If the radio station is far away, the signal is weak, right? It's faint.
Yeah.
So you turn the volume knob up. The music gets louder.
Sure.
But did you make the radio tower transmit more power? Did your car antenna magically reach out and grab more radio waves from the air?
No, of course not. I just took the weak signal that was already there and boosted it.
Exactly. That is what ISO is. It is a gain knob. In the old days of digital, and still on many sensors today, this is analog amplification. The camera takes the tiny electrical charge from the pixel and runs it through an amplifier circuit to boost the voltage before it gets turned into a digital number.
Okay, so it's literally a voltage boost. Like a guitar amp. You play a note softly, but you turn the amp to 11 and it shakes the walls.
Precisely. But here is the problem with amplification. When you turn the volume up on a radio station that has a weak signal, what else gets louder?
The static, the hiss, all that fuzzy noise.
That is the noise. And in photography, we see that as grain, those speckled, ugly artifacts in low-light photos. And this is where the concept of the signal-to-noise ratio becomes the most important concept in this whole deep dive.
The SNR.
Right, which you have lots of light, lots of signal, lots of rain in the buckets. You don't need much amplification. So the noise floor is invisible, the signal drowns out the noise, but in the dark, the signal is weak. You crank the gain, you boost the signal, but you also boost the noise right along with it.
And the sources go really deep into what this noise actually is. I always just thought noise was the camera being bad. Like if I just spent $10,000 on a camera, I wouldn't have noise.
A common misconception.
But the research mentions photon noise, and it sounds, well, it sounds existential.
It is existential. It's one of my favorite concepts. Photon noise, sometimes called shot noise, is inherent to the physics of the universe. It is not the camera's fault.
Explain that. How is the universe making my photos grainy?
Light doesn't flow like a smooth stream of water from a hose. It's quantized. It arrives in little packets called photons. And the arrival of those packets at any given pixel is fundamentally random.
Random?
Totally random. Imagine you were standing on a sidewalk in a rainstorm.
Okay, back to the rain. I'm with you.
If it's a total downpour, that's your bright light. The sidewalk gets wet instantly and uniformly. It looks like a smooth sheet of water. That is a high signal-to-noise ratio. The randomness is drowned out by the sheer volume of raindrops.
Makes sense.
But if it's just sprinkling your low-light scenario, you see individual drops hitting the concrete. Splat, splat, splat.
Spotty, uneven.
It's spotty because of the statistical randomness of the arrival times of the drops. That splat pattern is what grain is. Even if you had a perfect God camera with zero electronics and no heat, a low-light photo would still look grainy because you are seeing the randomness of the light itself. You are literally seeing the quantum fluctuations of the universe.
That is absolutely wild. So when I turn up the ISO, I am just taking that splat pattern and amplifying it so it's easier to see.
You are making the splats louder. And on top of that, you are adding a second type of noise, read noise.
Read noise.
That's the electronic hum of the camera's own circuitry. Every electronic gadget has a noise floor. It's caused by heat, electrical resistance, interference. When you amplify the signal from the sensor, you amplify that electronic hum too.
So you have the universe's noise and the camera's noise, and you're just turning up the volume on both.
You've got it. Which brings us to this concept in the articles that really changes how you shoot, ISO invariance. The article in Contrastly called it counterintuitive, and they are so right.
It basically says that with modern sensors, the ISO setting doesn't matter. That can't be right.
It matters for the preview on your screen, for the little JPEG the camera shows you, but for the raw data, the actual information captured. On a truly ISO invariant sensor, yes, it often doesn't matter where you apply the gain.
Okay, walk us through the mechanics of that. Give me a practical example.
Okay, let's say you are shooting a concert. It's dark. The lead singer is under a bright spotlight, but the rest of the stage is pretty dim.
Classic scenario.
So you could set the camera to, say, ISO 6400. You take the shot. The camera applies the amplification, the gain right there in the hardware. You get a bright image on your screen, but maybe the singer's face under the spotlight is blown out.
It's pure white, no detail.
Exactly, because you amplified everything and the bright parts hit the ceiling of what the sensor can record. You clip the highlights.
Right.
Now imagine you shoot that same scene, same aperture, same shutter speed, but you set your camera to its base ISO 100.
The image on the back of my camera is going to look pitch black.
Pitch black. You'd panic. You'd think you missed the shot. But, and this is the key, because your modern sensor is invariant, meaning it has a very low level of that back-end re-noise we talked about.
Okay.
You can take that black WAV file into your computer, into Lightroom or Photoshop, drag the exposure slider up, 5 or 6 stops.
It looks the same as the ISO 6400 shot.
It looks almost identical. The noise is basically the same because all you did was apply the amplification in software instead of in hardware. But here is the magic trick.
Go on.
Because you didn't amplify it in the camera, you didn't blow out the singer's face, you save the highlights. You have all that detail in the bright areas that the other shot lost forever.
So by shooting in the dark and amplifying later, I actually get more dynamic range, more detail in the brights and the darks.
Exactly. You are decoupling the capture from the amplification. You are capturing the raw signal, however weak it is, and deciding how to manage the signal-to-noise ratio later on a powerful computer, rather than letting the camera's frankly dumb little processor make that critical decision for you.
It's about control. It's about saying, I will manage the signal-to-noise ratio myself, thank you very much.
And that phrase, managing the signal-to-noise ratio, that is the bridge. Because that is exactly what a CEO does. That is exactly what a global logistics manager does. They are trying to get a clear signal, a product, a profit, a shipment through a world full of noise.
And just like photographers have ISO settings, the corporate world has ISO standards.
The other ISO.
The other ISO. But before we get to the boardroom, we need to clear up a linguistic thing. I was today years old when I learned ISO isn't an acronym.
Chuckles. It's the most common trivia question in this field. It tricks everyone up. Most people think it stands for International Standards Organization.
Which would make perfect sense.
It would. But in French, which is one of the official languages of the organization, it's called Organisation Internationale de Normalisation. So the acronym would be OIN. And in Russian, it would be different. And in Spanish, different again. The founders didn't want a changing acronym that depended on the language. So they chose ISO, which is derived from the Greek word isos, which means equal.
Like an isosceles triangle, two equal sides.
Exactly. The concept is equality. Standardization makes things equal. It levels the playing field so that a bolt made in Brazil fits a nut made in Germany. That's the whole idea.
So we have this organization in Geneva, Switzerland, and it's churning out these standards. The two big ones in our source stack are ISO 9000 and ISO 14001. I want to start with 9001 because I see it everywhere. It's on the side of plumbing vans, on websites, on huge factories. ISO 9001 certified.
It is the absolute gold standard for quality management. The most famous standard in the world by far.
But here's the thing that confuses people, and it confused me. If I buy a toaster from a company that is ISO 9001 certified, I assume that means it's a high-quality toaster. I assume it's, the best toaster.
And that is the trap. That is the fundamental misunderstanding of what 9001 is.
So it's not.
ISO 9001 has absolutely nothing to do with the subjective quality of the product. It does not guarantee that the product is good in the way a consumer thinks of good.
Explain that. How can a quality standard not ensure quality? That seems like a contradiction.
It ensures consistency. It ensures that the company has a documented, repeatable system in place to deliver what they promise to deliver.
Okay.
The classic example, and it's a big grim, but it's very effective, is the concrete life jacket.
Concrete life jacket?
Yes. Imagine I start a company called Heavy Sinkers. We make life jackets out of concrete.
A terrible business model.
An objectively terrible product. It will kill the user.
Yeah.
However, if I have a documented procedure for mixing the concrete to the exact right density, a rigorous inspection process to ensure every jacket is the correct weight and dimensions, and a system for logging customer complaints.
Even if the complaints are strictly from next of kin?
Precisely.
Yeah.
If I have all that documented and I follow my own procedures, I can technically be ISO 9001 certified.
That is hilarious and terrifying. So you are certified for being consistently terrible.
You are certified for having a quality management system that functions as designed. The standard checks the process, not the result. Now, in the real world, ISO 9001 also requires customer focus and continuous improvement.
Ah, so there's a catch.
There's a catch. So if all your customers are drowning, the standard forces you to analyze why and take corrective action. So eventually, you'd have to stop making concrete life jackets. But the certificate itself, it's about reliability.
And for a business-to-business relationship, that reliability is actually more important than luxury or premium quality, isn't it?
100%. If I am a car manufacturer in Detroit and I am buying brake pads from a supplier in Malaysia, I don't necessarily need the brake pads to be made of gold. I need them to be exactly the spec I ordered.
Every single time.
Every single time. I need to know that the millionth brake pad will be identical to the first one. I need to know that if there is a defect, the supplier has a system to trace it back, find the root cause, and fix it. ISO 9001 is a shortcut to trust. It tells me these guys have a grown-up system in place. They aren't just winging it.
So it filters out the noise of incompetence or inconsistency from the supply chain.
Exactly. It reduces the read noise of the supply chain. Perfectly put.
Okay, that makes sense. Then we have ISO 14001. This is the environmental standard. How is this different from the quality one? Is it just the same thing but for trees?
In a way, yes. The core difference is the primary stakeholder.
The stakeholder.
Right. With 9001, the system is almost entirely focused on the customer. Is the customer happy? Are we meeting their requirements? With 14001, the focus is on the rest of the world. Are the neighbors next to the factory happy? Is the river happy? Are the government regulators happy?
So it's about managing your external impact.
It's exactly. Managing your impact on the environment, reducing waste, and ensuring you are complying with all the relevant laws and regulations. The customer is society itself.
And looking at the 2015 updates to these standards, there is a term that keeps popping up: risk-based thinking. It sounds like they are trying to make these standards less about checking boxes and more about, I don't know, predicting the future.
That was the massive shift, a huge philosophical change. In the old days, you had this thing called preventive action, which was usually just a form you filled out after something almost went wrong.
Reactive.
Very reactive. Now, the standard demands you look at the entire landscape before you even start. You have to ask, where is the uncertainty? What could go wrong in our supply chain? What if the government changes the environmental laws? What if climate change causes more flooding near our warehouse?
It's proactive. You have to anticipate the noise before it happens.
It is. And this brings us to the biggest headache in the corporate world, which the sources describe in excruciating detail as audit fatigue.
This sounded painful just reading about it.
It is the corporate equivalent of death by 1,000 cuts. Imagine you are a factory manager. You have a job to do, make widgets. But on Monday, the quality auditor shows up. He wants to see your training records to ensure staff are making mistakes.
Okay, you pull the files.
Right. You spend all day in the file room with him. He leaves. Then on Wednesday, the health and safety auditor shows up. He wants to see the exact same training records, but he's checking to see if the staff know how to not get their arms ripped off by the machine.
Same data, different lens.
And just when you think you're done, on Friday, the environmental auditor shows up. And guess what she wants to see?
The same training record.
The same records. But this time, to see if the staff know how to properly dispose of the toxic waste the machine produces.
So you have spent 3 days hosting 3 different people, showing them the same files, answering similar questions, just to satisfy 3 different standards.
And you probably have 3 different massive 3-ring binders sitting on the shelf. A quality manual, a safety manual, and an environmental manual. And very often, they probably contradict each other.
How so? How could they contradict?
This is what's known as the silo problem. The sources use a great example of a chemical warehouse. It illustrates this perfectly.
Okay, let's break that down.
So you run a warehouse. You have a quality manager. His job, his performance bonus, is tied to product quality and cost. He finds a new supplier who sells a key chemical for 20% less.
Great. Looks like a hero.
Looks like a hero. Quality goal met. He approves it. But this new chemical is slightly more volatile. It requires a very specific, cooler temperature range to be stored safely.
Uh-oh.
The safety manager doesn't know about this switch because he's in a different silo. He's got his own budget, his own priorities. He keeps the warehouse at the old, warmer temperature because it saves on the electricity bill.
That sounds dangerous.
Now we have a risk of explosion. And the environmental manager, she's in a third silo. She's worried about the drainage system. If that explosion happens, the chemical spills and flows into the local river, causing a huge environmental disaster.
And none of them are talking to each other.
None of them. Because these 3 systems aren't talking, you have created a massive combined risk by trying to optimize just one variable cost.
You turned up the gain on cost savings, but you inadvertently turned up the noise on safety risk and environmental risk.
That is a beautiful way to put it, yes. And the solution to this, the holy grail in the management world, is what the handbooks call IMS, an integrated management system.
Which is basically saying stop having 3 brains and just have one. Stop running separate siloed systems.
Correct. And this integration was made possible by a really, really boring-sounding thing called Annex SL.
Annex SL. It sounds like a secret protocol in a sci-fi movie. A government file.
It's actually just a table of contents. But it's revolutionary. I'm not kidding. Before 2015, the different ISO standards were written by different committees who didn't really talk to each other.
The standards themselves were in silos.
The irony is rich, isn't it? So Chapter 4 in the quality book might be document control, but Chapter 4 in the environmental book might be legal requirements. You couldn't just merge the manuals because the structures didn't match. It was a Tower of Babel situation.
So NXSL was the universal
It
translator.
was a high-level structure. It was a mandate from the top of ISO that said, from now on, every new management system standard will use the exact same 10-chapter headings in the same order with the same core text.
Is there now?
Now, Chapter 4 is always context of the organization. Chapter 5 is always leadership. Chapter 6 is always planning. It's the same skeleton for quality, environment, safety, information security, you name it.
So now that factory manager can have one manual.
One manual, one single IMS policy, one internal audit program, and most importantly, one holistic decision-making process.
So let's go back to the chemical warehouse. How does an IMS fix that?
Okay, so with an integrated system, when that quality manager gets the proposal for the cheaper chemical, the process forces him to evaluate it against quality, safety, and environment simultaneously.
It's all on one form, so to speak.
Exactly. The risk assessment isn't just, will this meet customer spec? It's also, what is the flashpoint? And what are the disposal requirements? You spot the volatility issue immediately. You calculate the cost of upgrading the warehouse AC unit to keep it cool.
And you realize it completely wipes out the 20% saving.
And you don't buy it. You avoided the risk because you saw the whole picture. You didn't just look at one signal, you looked at the entire system.
That is real efficiency, not just cost cutting, but risk reduction.
It's the elimination of noise. You strip away the bureaucracy of running 3 separate systems to get to the clear signal of good business management.
This is a perfect pivot point. We've gone from the sensor managing the signal of light, we've gone to the corporation managing the signal of risk. Now I want to zoom out to the biggest scale possible, the map of the world.
From the boardroom to the globe.
Because it turns out there are physical places on Earth designed to be the ultimate low-noise environments for business. We are talking about free trade zones.
This is where the concept of standardization hits the geopolitical road. Hard.
The sources list all these places: the Shannon Free Zone in Ireland, which was one of the first, the Maquiladoras in Mexico, right on the U.S. border, Jebel Ali in Dubai, which is massive, various zones in China, the Philippines, Brazil. Define a free trade zone, or an EPZ, an export processing zone for us. What actually are they?
Economically speaking, they are a country within a country. They are designated geographic areas, often literally fenced off with their own security and customs gates, where the normal rules of the host nation do not apply.
What kind of rules are we talking about?
Mostly tax and customs rules. Imagine you are a company like Apple or Nike. You have a massive global supply chain. You are buying chips from Taiwan, glass from Korea, plastic from China, cobalt from the Congo.
A truly global product.
And you want to assemble all those parts in a factory in, say, Brazil, to then sell the final product in Europe and North America. If you used a normal factory in Brazil,
You'd pay import taxes at the border for every single one of those components.
you'd pay tariffs on every single screw and microchip, and your goods would get stuck in customs inspections for weeks. It's a bureaucratic nightmare. That is friction. That is noise.
So the free trade zone removes that noise.
Completely. In an FTZ, the government essentially agrees to treat the zone as if it's outside their customs territory. You can bring all those parts in duty-free. No tariffs, no taxes.
So you import the raw materials tax-free.
You assemble the phone or the sneaker inside the zone, and then you ship the finished product out to America or Europe. You never paid a cent of Brazilian tax on the parts. You only pay tax maybe on the finished product when it hits the store shelves in the destination country.
And the sources mention these things called tax holidays? That sounds even better.
That's the real cherry on top. To attract these big multinational corporations, governments will say, look, if you build your factory here and hire 5,000 of our citizens, you will pay 0% corporate tax for the first 10 or 15 years.
Why would a country do that? It seems like they're just giving away the store.
They want the jobs. For many developing nations, it's a desperate bid for development. If I'm the leader of a country, I have plenty of labor, but I don't have the capital to build factories or the technology to compete globally.
So you invite the multinational corporation in.
You invite them in. You give them the tax break. In exchange, thousands of your citizens get jobs. They earn a wage. They learn how to operate modern machinery. They learn about quality control, about logistics.
It's technology transfer. And hopefully some of those workers eventually leave and start their own smaller local businesses using those skills.
That's the ideal scenario, yes. But here is where the connection back to ISO becomes so critical. A factory in a free trade zone in Vietnam, is completely useless to a German car company if the parts it makes aren't perfect.
Right. The tax break doesn't matter if the product fails and causes a recall.
The tax break is irrelevant if the signal is noisy. So the ISO standard acts as the passport. The free trade zone provides the financial environment, low cost, no tariffs. The ISO system provides the operational environment, guaranteed consistency, repeatable processes.
They're two sides of the same coin.
They work hand in glove. The standard ensures that the factory in Vietnam runs exactly like the factory in Germany, even if the culture and language are completely different. It creates a standardized pocket of industrial space.
It creates a standardized world. It's like a frictionless tube for capital and goods to slide through across the planet.
That's a great image. Exactly. But there is a dark side to this frictionless tube. And the sources are pretty explicit about it. They call it the race to the bottom.
We have to talk about this, because if every country offers a free trade zone and every factory inside is ISO standardized, then everything is kind of equal, right? The quality is the same everywhere.
And if the quality and the process are standardized and equal, the only differentiator left is cost.
So the corporations can just shop around for the cheapest deal.
They do.
Right.
It creates a massive bidding war between developing nations. A big corporation can go to country A and say, country B is offering me a 10-year tax holiday, and they'll build the roads to the port for me. Can you do 15 years?
Or worse.
Or worse. Country B says, I don't have to deal with labor unions. Can you match that? Or country B has more flexible environmental regulations. What can you do for us?
That is a dangerous leverage for a company to have over a sovereign nation.
It is. The source material references the work of critics like Naomi Klein, specifically her book No Logo, which really blew the lid off this in the 90s. The critique is that these zones effectively become legal vacuums. In the quest to remove noise for the corporation, to remove taxes, regulations, and labor friction, the host countries might be removing the fundamental protections for their own people and their own environment.
And the term footloose was used in one of the reports, which gives me this visual of a factory just getting up and walking away.
That is effectively what happens. It's called footloose capital. Because the factory is standardized, because it follows ISO 9001 and uses standard machinery that can be bought anywhere, it isn't deeply anchored to the local culture or the location.
It's a cookie-cutter operation.
It is. So if the tax holiday in country A expires in 10 years, the corporation can just pack up the most valuable machines, ship them to country C that's offering a fresh 15-year look, and leave an empty building behind.
And the host country is left with an empty shell.
Left with the infrastructure they built to support the zone, the roads, the power grid, but no long-term tax revenue from the company they bend over backwards to attract. It's a very high-stakes gamble for developing nations. They are trying to catch the wind of global trade, but that wind can shift direction overnight.
It brings us right back to that central theme we started with. We are stripping away noise. We stripped the grain from the photo to get a clean signal. Right. We stripped the bureaucracy from the management system to get a clear signal of risk. We stripped the tariffs and regulations from global trade to get a clear signal of profit. But in doing so, are we stripping away something essential, something valuable?
That is the big philosophical question hanging over all of this, isn't it? Noise is often just context. Noise is local texture. Noise is the fact that labor laws in France are different from labor laws in Vietnam for historical and cultural reasons. When you use standards to smooth all of that out, you get efficiency, absolutely. You get cheap sneakers and you get amazing cameras that can see in the dark.
But you also get a world that is somewhat flattened, homogenized.
A flat world, to borrow another famous phrase. And it's funny, if you look back at the camera example, what are photographers doing now? What's the trend?
They are adding grain back in.
Exactly. We spent decades perfecting the clean, noise-free digital sensor, and now the most popular filters on Instagram and those popular presets you can buy for Lightroom are designed to meticulously add film grain back into the image.
Because the perfect, clean, noise-free signal feels sterile. It feels fake.
It lacks soul. It lacks character. We crave the noise because the noise feels real. It feels human. It has texture.
It has a story.
And I wonder if we will reach a point in the global economy where we start to feel the same way, where the perfectly optimized, standardized, ISO-certified, just-in-time supply chain starts to feel brittle, unstable, and we start to value the local, the unique, the slightly messy noise of real human connection and regional resilience again.
That is a fascinating parallel. We optimize and standardize until we break the very thing we liked about it in the first place.
It's the cycle of innovation, I suppose. Standardization builds the platform. It creates the foundation. But it's the deviations from the standard that create the art, that create the progress.
Well, I will certainly never look at the back of my camera or a shipping container
Mhm.
or even a concrete life jacket the same way again.
Hopefully we can all avoid the concrete life jackets.
Ideally. Thanks for walking us through the hidden code of the world today. This was amazing.
My pleasure. It was a lot of fun.
And thank you for listening. Keep tuning your signal, and we'll see you in the next deep dive.